Hello. I want to talk about what I've done with the logiqub lately. I've recorded the Tetris clone, which I called Tetrominoz, and we're going to do a little code review. So I'm going to show it to you what I've done. So this is Vim, and here is the project. I'm just going to go through the files and I'm going to talk about random things. First of all, to launch the program, it starts in main like this. So this is the main file. Here we're just setting a path to find the modules, and the modules can be any number of things that are shared between different projects. So here you find the porting of the SDL2 library. So it's just an implementation of SDL2. Just a lot of code really. And here is a little switch between Linux and Windows. Then we have the functions here, and this builds a symbol table because I can start the application like this. As you see, we take but when you build the application, this language works by compiling everything on the fly. So basically, I don't have any bytecode. It's direct threading. So I just have a core interpreter, and then on top of that, I build the language. So we need to do the documentation and a very big code review about that. But just for now, this part is just about building a symbol table like you do for a dynamic library, where you list all the names and then you have the address of each function. So basically, when I build a disk for the game, if you look here, you can see I have a build mode, and when I save the disk, all the pointers to the SDL2 functions, they are no longer valid. So what I need to do is to reload all the addresses to make them valid again, because when you load the library, there is address space randomization going on, so it doesn't always load at the same address. Everything that is about the virtual machine and the core language always loads at the same address, so I can make a memory image and save it on the disk and reload it later. All the pointers are valid except from the addresses of the SDL2 functions here. So that's why I kind of need to do that. And then everything is loaded here. I don't want to go into too many details. And then these two are opaque structures. This is another structure. It looks really like a C struct. Basically, what this language does is that it can pretty much interface with any kind of C code. There are maybe a few things that I've not done yet. For example, callbacks can be really difficult to implement correctly. Still some things that I'm working on, but overall, for what I need, it's working really well. So once we do that, actually we have an application framework too. So that's the application here. That's where we load SDL2 library, and we also have an implementation of SDL2 mixer for the audio. So basically sound effects and music, that's where I do it. And then we have like everything that I need, like data structures like linked list, array, dictionary. Dictionary is actually used for the configuration file here. This is converted to a dictionary. I can show you real quick. So this is it. A dictionary key is just like a text with a name, and then dictionary value, basically a variant. It can be a boolean, integer, text. So I support those three, and then the others like fixed point and complex number. I don't know if I really need that, but things that eventually I will add. So this is commented. I'll do it later if I really need it. And then we have a dictionary entry, key value, and then the dictionary itself with methods, get, as, for to check if a key is in the dictionary. You have a try, basically return the value with a flag, true or false. If it's false, I don't return a value. If it's available, I return true and the value behind it. That's how it works. And basically the dictionary implementation is just this. What you see here is a bit strange. That's how I declare local variables. Basically, when I started this language, I didn't know how to implement, well, I did know how to make activation records because that's how the C language works, but for my language, I wasn't sure how to go about it. So I started like this, and I have a new syntax right now, not this file. So this is what I want here. The new syntax is a local block here, which is a little bit different. And basically this local block, I can like put it here with the start of the routine here. It's just not really set in stone how I will deal with it. For example, I don't like to start with local here and then having to repeat it here so many times. I want to improve it. Obviously, I know like in C you're going to do like int x and stuff like that, right? But because this is a single pass compiler and I want to do everything just one time and maybe a few optimization, but I had to think about a lot of things, and if I were to redesign it, maybe I would do it like C or some other language, but right now that's just how it is. So we have like the type, then local, and then the name behind it. Otherwise, for fields, do I have a class somewhere? Yeah, maybe I need to show like as a game, for example. No. Yeah. This is the same syntax, but instead of local, I use field because it's a member of a class. And classes, I don't name them classes, I name them types. So for example, because there is only one application, like you cannot have multiple application objects, doesn't make sense to me. So, because if you want to start another application, you start a different process. So this is basically a singleton, and the lexicon is just my way of doing a single instance of an object, which basically is just a namespace. Okay, so we start to do something like that is interesting here. This end here is not the end of the namespace because I reopen it here, but basically because I don't have forward declarations, I need to make a pause here, close the namespace, declare the window, because the window needs a few other things defined above about the application, and then once the window code is loaded, I can finish with the application. So this is the dictionary here that loads the configuration file here, and the code is here, just configure. So load from file and all the parameters that you've seen, that's how they are evaluated and set in the namespace that is here. That's how it works. And then we have a bunch of other things to basically create the application window. Let's see the code real quick. So application window, we need pointers to the window. It's basically OpenGL behind the scenes because I choose accelerated. If you don't use this flag, you can do software rendering, so the GPU is not involved. But if you want to use accelerated graphics, then you pass this flag when you create the window, and then you get the renderer, which you pass some pixel data, and then it creates the textures for you. Basically, we need to see the rendering loop, which is normally paint. No. Oh no, it's named video. Okay. So basically, that's what it does here. When I call video, it looks for any windows. It initializes a linked list iterator, and then it does next, and for each windows, it paints the window. the application loop is basically this line here. So now it's just going to check the time. This is going to check for events. This is going to do some things for the animations, so update some variables to make the sprites update. This is the painting the window, and this is playing the sound and music. And wait is just giving up some CPU time so the application doesn't lock up the system. And basically a bunch more code. As you can see, some things are commented because I've not finalized everything yet, but that's basically some things that I can use for every application in common. So back to the Tetrominoz stuff. Main. So we create a window after the application is initialized, and then we load the sound files, which are here. Yes, all the sound files are here. I picked them up on OpenGameArt, as you can see here. I was very lucky because for many of the sound effects that I use in the game are really good for Tetris. Like, I was surprised at how well it was matching to the design of the game. So I was lucky with this. And the music, so there is one music for the menus, and then 6 others for the gameplay while you're playing. So I need to set the proper music every time I'm load the scene. Oh yes, I need to talk about the scenes a little bit later here. So this is just the game implementation, basically the game engine. Here just some icon and text. So if you look here at the top of the screen, you see the name of the artist and the title. And if I try to play, it's changing. So that's why I have this component here, a text box for the name of the music, and a little icon here, which is the little music symbol that you see next to the text. And then we have the scenes. A scene is basically a screen. So this is a screen, the scene. And if I go to the leaderboard, it's another scene. If I click here, the leaderboard is empty, so there's nothing to see here. But if I play, and I can type my name here, and then it shows up in the leaderboard. Yeah. When you close the game, the leaderboard is not saved yet. I have a lot of work to do about packaging the application so people can download and play it. What I want to do is to release the virtual machine with a lot of games, and each game will have documentation and source code, and hopefully I can continue to find like open source resources for the music and sound, because I can draw a little bit. I can do some pixel art, but I cannot do music. Just don't know how to do it. So hopefully for each game that I will make, I will be able to find some decent music. Let's see a little bit of code. What is interesting? So that was the sound, here is the music. That's just a screenshot, hopefully. Yes, the game implementation. So here it's the same thing, the game module. We load everything that we need, especially the score here, which we will see later. There are two scoring routines or styles or mode of play, I would say. So in classic you don't have a bonus for hard drop here. Hard drop is 2 points and soft drop is 1 point for each cell when the piece is moving down. So classic doesn't have it, but modern does have it, and the scoring is a bit different. 4 lines is 800 points, the Tetris, and 4 lines is 1200 in classic. But the single line is 40 here against 100 for modern here. So basically when you start the game, if I go to start, you need to pass the mode, and based on the mode I call score set classic or score set modern, as you can see here. And yes, I want to talk about the pieces, how I represent them in the game. So basically I take a size here, and then I build an array, and the number is the color of the piece. So each piece has a different color, and that's the index of the sprite that I draw on the screen, basically. So the O piece, which is a square, just 2 by 2. The L piece is a 3 by 3, and each time this is, as you can see, one rotation, and the next rotation clockwise is this, like this, and then this is the next rotation and next rotation, and there are only 4 rotations. So that's how it's done, and at the end of it all I have all rotations in a list, and this is basically how the rotation works. So I can decrease the rotation or increase it. I can get a block within every rotation data. So basically I get the size. With the size I know how to get to every cell, and this is useful to draw the piece, but also to check for collisions. So that's how I implement the rotation, and then we have the piece. So the piece is just a type, and then the rotation is also I think I forgot something. Yes, because this is important. Okay, so the rotation value here is the index. So this is within this rotation data. This is index 0, this is index 1, this is index 2, and this is index 3. And then we go back to 0 here. So basically, each piece has a rotation field, and within that rotation there is a value that tells me if I'm on rotation 0, 1, 2, or 3. That's how I do it. So after I've done that, I build all the pieces. Yes, this here is a macro, and create here is another macro. Actually, I want it like this. I have two styles of commands. This is a line command, so this is until the end of the line, and this is a block command, so it goes like this only. As you can see, this is not commented here, but if I do this, it gets commented. That's how I did it. And there are two block commands because when I first started it, the compiler is going to parse this block to know how many parameters the routine needs. And this is ignored. It stays on the data stack or the parameter stack, but this will go in the activation record, which is all the parameters of the routines. So basically this is the self pointer in Python, or this in C++, and this word here, the brace, opening brace, is going to activate the record and take all the parameters of the routine of the data stack, put them onto another stack, which is the code stack just for this code to execute, and then at the end of the routine, this closing brace here is going to deallocate all the variables on the activation record. So it's basically the function prolog and function epilogue in C, or assembly code rather. That's the same thing that these two are doing. Okay, so I was talking about macros. So yes, all these macros, it's just syntactic sugar, especially the with self here. It's basically declaring the type of self. Basically self is going to be piece, a local pointer like this, and then I will write with self, and then so the with block allows me to not write self every single time. So basically, when I have a with section like this, I don't need to write self anymore, because I say to the compiler, every time you see a dot without a name before it, you know the name that is with the with. And that's basically what I like about this language that I created, I can invent whatever syntax that I think I need, and I'm not stuck with something that I don't enjoy, and a lot of boilerplate and whatever that I will not be comfortable with a programming language that I cannot change the syntax or add new things to it. For example, in this language, you can redefine the plus symbol to mean minus. Basically, I can do that. So normally you would have this, but in my language, it will, if I redefine, basically, before it's like this, and then afterwards, it's like this. What I mean is, because now plus is minus, it's become 1 minus 1, which means it's 0. Something that you can do in this language that you cannot do in almost any other language except maybe Lisp and Forth, obviously. Because the logiqub virtual machine is based on the Forth language, so that's why I really enjoy working with it. You can do whatever you want. Total freedom. It's amazing. And the only price you have to pay is that you have to write everything in postfix. And one advantage is that you don't need parentheses. So basically, like, let's say you want to do something like this. 2 times 3, which is basically 8. When you write in postfix, basically you do 1, 3 plus event to star. You don't need the parentheses anymore. So, and something to know is that every programming language needs to process this form and transform it like this anyway. So I'm just doing some work for the compiler because he has to do it anyway, so it doesn't matter to me that I need to use postfix notation. I'm comfortable with it, but some people might not like it. I don't see why. Because Japanese works the same way. The verb is at the end, so I don't think it's unnatural or anything. Let's talk back about the game implementation. So some data, whether the game is over, the current piece, the next piece, the bag. I use a 7-piece bag here. It's not random. Some Tetris implementation, you have like a random number generator. I don't do that. Basically, you empty the bag. Well, you fill the bag first, and then when it's empty, you fill it back. So inside prepare next piece, I pop the first piece, I assign it to the current piece, then I set the position of the piece. Yes, that's it. So 0 is the first row, the top of the screen, and then this is just calculating how to center the piece in the middle of the playfield. And then if the bag is empty after the pop, I fill the bag, and then after that I get the first piece of the bag and I assign it to the next piece so that you can preview what the next piece will be. And basically the whole game engine is implemented here. Could talk a little bit about the collision check. What we do, it's a bit difficult to see without some kind of diagram, which basically is why I have some kind of test file here. So this is the text implementation of Tetris, kind of. Basically, you can start the game and call methods on the game without the graphics. So let's do that. Basically, I just set up the game and then I do a couple of things. Like, for example, the last two play fields, it's just me filling 2 rows at the bottom and removing 1 row. As you can see, it's here. I fill row 20 and row 21 with 8. 8 is basically the gray that you see when the game is over. Every piece has a color, but when the game is over, I fill the screen with gray blocks, and the color for gray is 8. And then another clear here. And this is just to print. So when you start developing the game, it's good to be able to just do everything with scripting like this. And also this works like a scripting language. I forgot to mention that. So this line here is exactly how you will do the same thing for, I don't know, Python, except this is for our new language. And as a parameter, you need to load the core extension, because the base executable is kind of limited, because I didn't want to write everything in assembly code. We can have a look at it real quick. Oh yes, I need to. Okay. So this is the assembly code implementation of the language, and I've done it in the past to implement a lot of routines like this. It's basically an array of function addresses, and you dispatch from one function to the other, and that's basically how you can reuse a lot of the native routines like this. This is pure assembly code, but you take the address like this, and this address you can reuse it in an array like this to create functions. And I didn't want to write too much code inside of this. Instead, I have a core extension here, and this extension is basically the meat of the project. I do a lot of the heavy lifting here. I can't even explain how much stuff I'm doing. For example, here is just some declarations to how do I say this? I don't know how to explain this simply. This is for input-output, so I have a lot of words, a lot of symbols rather, to do input-output. This is, oh yes, dump. Yeah, that's a perfect example. So without this declaration here, I cannot examine some memory location. But once it's done, this is dump here. When that's done, I can basically say, okay, let's see. This block, you show me 36 bytes, and then you exit. And that's what it does here. As you can see, I have starting from block 3072 and all the bytes that I requested. So that's 9 cells, 9 times 4. We are in 32 bits, so every cell is 4 bytes. 9 times 4 is 36. So it's dumping the data that I requested. And I'm doing this for a very, very long time. Very long time. And if you know the fourth language does not have like dot notations. Normally, you cannot do what I'm doing here with, for example, yeah, no, that's what I want here. So this will be a self, which will be an address on the data stack, and then you would have score. No, not like this, score, which is the field, which will be an offset. So first you have an address, and then you have an offset, let's say, I don't know, 12. That's an offset to the address, which is score. And then you have a routine, which is clear, which is at a specific address. So I don't know, like, let's say this is the address. So you call clear on the self, which has whatever address it is. I don't know, maybe something different with this offset, and that's basically how it works. But everything in the fourth language would have to have spaces in between, and for me that's a problem, because here this clear, we don't know how to look for it, so I would have to write it like this, because the clear routine is in the score lexicon, basically the score class. And writing the code like this, when I was in the second version of the virtual machine, that was not sustainable. So I had to give this up and redesign the whole virtual machine stop writing everything in assembly code and have an extension like I did here, where I can define please. Oh no, okay, I know. I need to escape it. Yeah. The dot here is an extension to the language to be able to handle dot notations. And everything, even like the local variables, which in Forth you typically don't have it. You have like those variables, but the problem is static global variables. You cannot have recursions, or when one routine is calling another, you have the risk of just overwriting whatever was in the variables because you didn't create a new stack frame. So the best way is to do like every other programming language and have activation records. You cannot always just use the data stack and global variables like this. That's not enough, especially when you start making some bigger applications like games. It's just nearly impossible. Maybe it's me, but I don't think you can avoid doing this. I tried to not use local variables and activation records before. I managed to make a Tetris game without it in version 2, but here in version 4 it's just 10 times better. Like if you have a quick look here, normally I have a script for lines of code, and you can see like almost 50k lines of code. So when the project is really big, you cannot afford to do it the fourth way without the dot notation, without the local variables. It's just not sustainable. So yeah, let's make some progress on the code review. Almost 1 hour already. What's the most important thing? So yeah, the game implementation. So lot of function to clear a row when the row is filled. This is how we check that the row is filled. When there are multiple rows to clear, for example, we have a triple, double, etc. We just check which row is filled, and then when we finish counting how many rows are full, we just invoke the scoring function with the count, and then we clear the counter. This is an array with all the row indices where we need to clear, and when we just finish everything, we need to clear this array. That's what happens here. And this is to find all the rows that are full, etc, etc. This is to lock the piece when it hits the bottom, or it collides when the pile is falling. So a piece fall is just an increment of the y coordinate, and a lot of stuff. I can't explain everything because I don't want to make this too long. Let's see quickly. Game view. Yes, okay. So that's where most of the animation is implemented. So we have also a gravity curve. So the game is speeding up and we have like 30 levels. So for each level, I have a value, how many frames we wait before the piece is falling. So we wait 60 frames, which is 1 second, and then we go up until the piece is falling every frame at level 30. I die usually at those levels. I could probably finish the game, but I need a lot of practice, and also I didn't implement a spawn delay. In this implementation, I have input repeat delay, I have log delay, I have fall delay, which is the gravity, I have a land clear delay, but I don't have a spawn delay. Basically, when the next piece appears, you can pre-rotate or pre-move the piece so that at this speed the game is still playable. But without it, the next piece appears and you are late on the rotation, you're late on the positioning, and you just die. So I think I need this buffer, this input buffer to be able to play at the highest speed. Okay, I will not go into all of this, but most important things is the paint here. So the paint has a couple of steps. We have the playfield, we have the piece, and we also check if there is a line clear animation, and if the game is over. In those two cases, we just return and we don't draw the piece. Otherwise, we draw everything. This is just setting the size of the textures, basically. This direct here is a destination rectangle that we use for drawing. Obviously, if there is no game and the game view has not been initialized properly, we just don't paint anything. This avoids a crash. This is the update. Paint before is how I update the game. So depending on the state, for example, it's paused, we don't perform any update. If the game is over, there is no update. If there is a line clear, we wait for the line clear. So we check if it's enabled. If it's enabled, we decrement the delay until it reaches 0, and when it's 0, we just perform the line clear, load the next piece, and then we return. And at the next frame, it's going to go through this all the way down, make the piece fall, and when the piece falls, if it hits the bottom or there is a collision, so the piece can no longer fall, then we set a log delay. The log delay is half a second, and when there is a log delay, we enter the log delay wait loop here. As long as there is a log delay, we return. So meanwhile, you can still move the piece left, right, and do rotations, but the piece does not fall. The piece is going to fall again after the lock delay is disabled, and then we perform the lock. We clear rows if there is anything. We load the next piece and basically let the game continue. And this is just some initialization code where this here, this closure here, is to avoid, if I go in the scene game here, so this is the game view, I need to write something like paint, on paint. This I need to write for every component, and it's annoying. So what I found is that, okay, every time I do initialize here on a component like this, I can just create a lambda function that will call paint for every onPaint event. And yes, I didn't talk about those events. So the application framework, let's see the scene code real quick. So the scene code, yeah, many things to talk about. Let's see. The scene is responsible basically for the layout of the elements on the screen. That's basically what it does. That's why there is a layout root, which is a scene view. And the scene view is just an abstract class, so you cannot there is no constructor for it. There is no like create, doesn't exist here. There is no initialize here. So basically every element of the scene will be placed based on position, dimension, and container. Right? Why was I speaking about? Yes, because of paint. So there should be on paint here. Yes, they are here. Invocable is just a function, a routine address, a function pointer, and basically every element of the scene has this declared, and controllable is the same for mouse input, keyboard input, and game controller input, which we can see like scene handler here. Does all those things. So you create a handler for the element, and once the handler is created, you have to create a sub-handler, because that's how I've managed to get it to work the way I wanted. For example, game input handler is a mix of controller and keyboard, because I don't want to write in the scene code here. Yes. So this is the input for the game. So down is going to do a soft drop, but up is going to do a hard drop. And we have left, right, same things. And what you'll notice is that we use a game input handler. And this is an abstraction which allows us to process both the controller, so the game controller, and the keyboard at the same time. And this is based on what we load in the configuration here. All of this is exactly the same as all of this. So that's how I do the abstraction of the game input. All right. Okay, so I have a component here for the game, for the view of the game, which is basically the play field and the game input. So let's go at the top of the scene. This is some info, how many lines, the score, the level. This is the piece preview, and the game view and game view handler. The handler is the input, and this is the play field. And then we have the music, little icon, and the name of the music that is playing. And this is some menu. Oh yes, I didn't talk about the menus, and now I build them. Basically I have there is yes, because we're in the game scene, there is a pause. So the pause is basically then I pause, and then as you can see, I can only move in the menu. If I choose continue, then the game continues. Back, I just exit. So what happens is that there is a grid box, and I fill it with 2 text boxes. So back and continue, as we've seen. I set a source for the grid box. Initially it's not visible because when I'm playing I don't want the pause menu to be visible. I set the handler, and that's basically it. We need to see how the menu works. So this is for up and down, so just moving the cursor inside the grid box. This is unpausing, and this is no. What's the pause? I always forget what is the pause. Okay, the pause is here. So when there is a pause, I set the pause in the game view, I made the menu visible, and I push the handler onto the scene handler. So basically I have a stack of handlers, and the top handler is the element that is going to process the input. So when there is when I'm playing, I take input for the game, and when there is a pause, I push a new handler, and the menu takes priority over the game. And when I unpause, I drop the handler here so that the game can take back the input. That's how I do it. No. Yes, and setting the sound here also. And basically that's how a scene works. So everything is built the same way. You set the scene, you add visual elements, so everything that you need to paint, you add it like this, and you add a few handlers when you do push handler to get the input, and everything works like this. And for the layout, let's see, dimension, yes, for example this, the piece preview, I set the dimension of it, which is scaled based on the layout route. I have a content scale. For example, if I want to make it smaller, I can set it to 2. Obviously, I cannot yet make 2.5. For example, my language does not have floating points. It's all integers because that's all I needed. But for scaling like this, I think I will need to implement floating point numbers. And it's going to be annoying because, as you know, I already have a definition for the dot, and here it's going to need to be able to handle numbers also, and I was not prepared for that, so something to do in the language still, I guess. Let's see with so that's a game scene. I set the scale to 2. Everything doesn't line up the same way, but you can see that everything is just smaller. So the menu is at the right place, the playfield is at the center, but the line score and level, they are not set up the same way because I didn't set up that I still need to work on. Okay, let's see. So that was the game scene. There is the main menu, which is basically all that you see, classic, modern, the leaderboard. Oh, this configure screen is for all the options. All the settings, however, when you reset the delays, these are coded here and you cannot configure this. So I want to have a scene with a menu where you can change those values. Obviously, this should be a custom leaderboard, because you can, otherwise you can cheat and you put as much delay as you want and you can play perfectly, basically, maybe. But we don't want that, so it's going to be no leaderboard or a separate leaderboard if you choose to configure the game to have different values. Okay, so there's not much going on here. And finally, the leaderboard thing. It's just oh yes, we need to see like the score. Yes, at the end of the score file, you get 2 leaderboards here with 16 entries, and the scene here is just going to show whatever was in those leaderboard arrays, classic and modern. And it's a little bit tricky because I have 2 cases. When I want to load a scene, let's see, the menu here, yes, so here I'm passing empty data, an empty context to the leaderboard scene, because when the game is over, is this the right file? Yes. When the game is over, basically I hide the game scene and I show the leaderboard scene. But I want to pass some context to the scene when the game is over, but inside, when I'm in the main menu, I don't want to pass anything. Instead of having a global variable, I prefer to set a context pointer like this, and I think it's a decent solution to pass information from one scene to another. I'm not sure if that's the best, but I still think it's better than having like a bunch of global variables and doing it that way. In the scene code, you can see there is a data context here. So yeah, that's how it works for the leaderboard. Based on the context, like you see, I change the music when the game is over and go back to the menu music, and then I check the context, and if there is a context, this means there is a new score, and I check what is the mode to load the correct leaderboard, classic or modern, and then I check if it's a new high score. If it's not a new high score, I just return. Otherwise, I show a virtual keyboard so the player can set his name, and then this part was tricky because it's basically a dialogue. What I was doing before is when I load the virtual keyboard, I do it in another scene, and in this case, I didn't want to create a new scene. So I have to show the leaderboard, push its handler onto the scene so that it takes priority, and afterwards here, when it's done, on submit, when you set your name, I drop the handler, I add the keyboard, I transfer the name inside the new score, and then I call set score, and set score is just going to append the score to the leaderboard and sort everything. And sort is just takes a comparator function, a comparator routine here, and do sorting, which is inside array.cube here. Sort. It's not like the best sorting implementation. This is very old code. Like when I first started creating this language, I wrote this, and it's not the best, but it works. We have to improve it a little bit later. And yeah. So even like to create a simple game like Tetris, there is quite a lot of things to do and to think about. Implementing the game, doing some animations, having a clear delay, log delay, spawn delay, and all those things. And then you have to think about the packaging, all the sound and music, and you have to create also a virtual disk here. I have to think about doing this. I already have some applications with a disk, for example. This one has a disk. The chess has a disk. But this one doesn't have a disk because I want to change the format of the disk to compress the data. For example, ici, this tile set. Oh yes, I need to show you how I draw everything, and that will be useful. So it's a tile editor. And yeah, yes, okay, maybe this works. Okay, so that's how I draw everything. And all those icons that you see here, they're reused to make the scroll bar, stuff like that. So if I click here, you can see this is the logo, logiqub logo. Oh, this is the little music icon that we use in the Tetris clone. And this page, yes, this page is a page for the Tetris blocks, each color, and 8 is a gray one. Which is used when the game is over. This doesn't belong. It was just some ideas when I was preparing for the space shooter, which is the next game that I want to do, by the way. This is some turrets, some explosion, some numbers for the score, and this is the chess stuff. And the resolution for chess is like 16 pixels by 16. It's too small. Like for the logo here, it's 32 by 32. But as you can see, I have to use 4 tiles because when I started, I didn't need more than 16 by 16 tiles. And now I need to expand and handle some 32 by 32 or more, and I need to write some code to handle this new format. And also the pages in the middle, they're empty, and I don't ignore or compress this file. So there is a lot of work that I need to do before I can finish the virtual machine and all the games that I want to release. Alright, almost 1 hour and a half. That was a pretty long code review. But I think, yes, we talked about, yes, the piece view is just a simple, very simple view component with just some kind of paint. This is the piece preview, and I have a to-do here because this code is basically the same code that is here to paint the piece. Almost the same. So I want to maybe merge the two if it makes sense. I'm not sure yet. We see how scene works. Yes, and we've seen the tile set with the tile editor. So yep, I think that's it. Many more things to talk about, and I have a video about like setting a high score and just playing this game. I also have a presentation of why I created this new language, to make a very short explanation. Basically, I wanted to make games, but every time that I use a programming language or framework, I don't like it because I don't have enough freedom, and or the performance is not there. For example, like Python is slow, or the tools are not maintained anymore because the main developer is gone. And I just wanted to do my own thing, and also I wanted to learn how to do everything myself, basically. So create your own programming language and your own application framework, and to figure out how to do everything yourself without using like an IDE, or, well, Vim is an IDE, but as you can see, it's not like I have a debugger and everything done for me. Even though I can try to use GDB, GDB doesn't know this language, so it's useless for GDB. The only thing I can do is I can show this to you real quick. Let's see. Something that executes only once. Maybe here. No, don't like it. Game init. Yeah, game start rather. So one thing I can do is I have a tracer here, and I can do something like this. And when I start it, hopefully, oh, that didn't work. What did I do wrong? Oh, I didn't start the game. That's why. I need to start the game. Alright, start the game. And as you can see, I can see what happened when I was executing this routine. And I can do some debugging like this. I also have the memory dump that we've seen. For the compilation, I can do like this. Inspect. And so inspect is going to basically show me a dump of the code for this routine and show me all the instructions. So basically that's my own assembly code for the virtual machine. And I can see everything that's going on here. And when I do like compiler optimizations, I can see what code has been generated and then make decisions about the code that I see, if I see something that can be improved based on the output that I see from inspect. And I can do basically whatever I want, like this kind of freedom, especially to be able to change the syntax of everything. I just like it so much, especially for the fact that I don't have a big compiler, like the binary is very small. It executes instantly, as you can see. I'm always like waiting for the for some kind of I/O, but the performance most of the time is within 2x of C. Python is 10 times or 100 times slower than C sometimes. I cannot use those language, like when making graphics, 10x is just too much. I need like 1x or 2x is workable. So I wanted a scripting language that I can invoke like this, which is really fast, which I can change the syntax of, and I can integrate with some C library like this. That's why I created this new language. And every feature that I need, like closure, lambda, many things, so much code that I've written over the years on this project. Like, this is very interesting. This is basically something that you cannot do in C, which is having direct register access, and here is just easy. I even have something for a JIT compiler, just-in-time compiler. Yes, I have an example here. It's commented because it's kind of a prototype, but I can generate x86 code on the fly, and so many things that I can experiment with. So hopefully in a couple years everything will be stable on Linux, Windows, Raspberry Pi, ARM, x86, maybe RISC even, and yeah, that will be a very, very good tool. And maybe some people will enjoy, most people will not enjoy what I've done, but yeah, that's it for me.